which will contrast the differences between the three rules. What are the three rules, you dumbass? What are the three rules? First is cache rules, next is authority rules, and next is partition rules. You know, right, what these three has, these three contains. So when a policy change, just at controller, what will happen? So this will time out, cache rule will time out, and this will change. Yeah, if your rule change at controller, then it has to change at switch level, right? It will change, and partition will not change. Will not change mostly. But if it changes drastically, then it has to store at another switch. So then partition might change. So if policy changes at controller, this will happen. Cache rules will timeout, and authority rules at authority switches will change, and partition may not change mostly. If topology change, remember this. If topology change, what will be most affected one? You dumbass. What will be most affected one? This will not change because this is all about rules. This will change drastically. It will change. Okay. If you guessed it correctly, then you are smart ass. So host mobility. When a VM machine is moved, what will happen? This will time out normally. Cache will always time out, and no change, and no change, because this is related to switches, right? So it will not change, and this is no change. Okay. If topology changes, why would rule change? Rule won't change. These rules won't change. These are policy related. Okay, these are policy related. These are policy related. These two are. Let me try another color. These are policy related, and this pitch here is related to partition rules. Okay. Yeah, this is all about floatable. This is all about DIFANE and the types of rules it has. Now going to CAB. What the fuck is this CAB? I will tell you. So the problem with storing the rules. So it is cool. We are storing the rules, and storing rules in switches is cool in DIFANE. But can we make this any better? Can we make it better? Where is it lacking? Why should you think about making better? If you want to make something better, means it is already not that good, right? Okay. So why is it not good? So overlapping of rules, like I have already shown you in geometrical representation, there are rules like this, right? When you, this is R1, part of R1, R2, R3. So you have to take this, right? Then you have to store all this part, and you have to store this part in different switch, or you can store this part and this part. This is all very ambiguous. Rules will be repetitively stored in the switches. That is the whole fucking problem. It should not be done. Rules cannot be repeatedly stored in the switches, then it will be memory efficient and it is bad. Okay, that is why we introduced concept called CAB. What is CAB? Caching rules in buckets. In CAB, we will have a different networking equipment called CAB controller. And I forgotten one other thing. Authority switches have a cache manager, like somewhere here. Like every authority switch have cache manager. Ingress won't have it. Authority switches have cache manager. Okay. Now, yeah, a CAB controller will be there. This in the CAB method. In caching rules in bucket, mm, not method. In this type of approaching the storing of rules in the switches, CAB controller is used. What the CAB controller does? So in a, so there is no difference in switches. No need to modify. Previously we have modified authority switches, like putting a special chip to create a cache manager. So here we don't need that. Okay, why? Because we have created a whole different equipment, so no need to modify the switches. So there will be no different name. So these are switches, right? Normal switches. And this is an STN controller, and this is CAB. Okay, this will write into the switches, and this is ingress and like a switch. So this is what's happening. So the rules will come to the caching um, in rules, caching rules in buckets controller, and here rules will be made into buckets in the controller, and these buckets will be stored in the switches. So what do I mean when I say rules are converted into buckets? What the fuck does this even mean? So normally rules are like this, right? Fucking overlapped and some shit. Rules will be normally like this. Okay, we make these into buckets. So these are the buckets. Okay, we will put these rules into a particular bucket, and we'll put these buckets, and this all processing is done in CAB controller. Okay, then the CAB controller will shit out the buckets info, and this buckets info is stored in the switches, not the rules directly. Okay, only rules within. Okay, uh, so yeah. Hmm. So what we will do is we will, so it should be bounded, like the number of rules in a particular bucket will be bounded. So this is done, this algorithm used in this conversion of rules to buckets is decision trees. Okay. Mm. Yeah, and this is so much efficient mm, than I think some other concepts like caching exact matches. You know, caching exact matches, right? And caching micro rules and caching dependent rules, and this caching bucket, caching rules in a bucket. This is caching rules in bucket. I don't know. This is a weird ass name, man. It should be like caching rules in bucket. This is a nice name. What the fuck mean? You have taken two letters from a single word. It is bad. You should take CRB instead of CAB. The paper should be renamed. That is the only problem I have. So, so if you use this, it will be super duper efficient in cache miss per second. Okay, cache miss per second is taken on y-axis and on x-axis flow arrival rate. Okay, and CAB is here, right? Just first I am telling for example, and this is CMR. Okay, this is CDR. Okay, and this is CEM. This is CEM. CEM, you know, cache exact matching. And this is, what is this fucking thing? This is CMR, cache matching rule. And this is the worst, CDR, cache dependent rule. And here this is CAB, or I will rename it as CRB. This is extremely good. See the difference. See, I may not represent correct values, but there is huge difference in the original graph. You can read it in the paper. You can hit caching rules in bucket. It is published on SIGCOMM or some shit. So, fully compatible with OpenFlow standards. Okay, that is the one thing. And this is a new wildcard caching system, as I have already told. I mean, I haven't told the exact term, but you might have figured it by the way, by the here. Okay. Now, this will reduce control network bandwidth, which are good, by the way, and flow setup latency and controller load. Yeah, it definitely reduces controller load because it is using CAB controller, and flow setup latency might be minimum, not much difference, and control network bandwidth. Yeah, it does. But I do. Do you think that bringing a new device which will increase more devices? Do you think it is efficient? Do you think DIFANE is more efficient than the CAB type of storing values? Like there will be no CAB controller and just directly storing. But it is already proved here. Like CAB is far more fucking more efficient. But at what rate? It is more expensive, right? Is it not? Because we are using a different fucking device like CAB, which will have a different computation processing, little processing power. Yeah, I think yeah, CAB I think definitely is more costly because it is using devices. But you should take in another thing in consideration because you are not using this. You are not modifying the switches, which might reduce the price because we are not modifying the switches. Yeah, maybe, but we are not manufacturing. Okay, anyway, yeah, this is the end of the week 7. Tomorrow I will do week